I'm Anil Kumar, and in this video I'm going to give you a few examples of functions which are always increasing or decreasing. So let me sketch some for you. Now whenever we look at a function, we are always seeing it as we move from left to right. That is to say, as we move from x value of negative infinity to x value of positive infinity. So what you can do is, you can pause the video, sketch few functions which are always increasing or always decreasing in their domain. So one of the functions y equals to x is a straight line, and it is always increasing. If we see from left to right, then the value for the function for a higher value of x is always higher, right? So if we consider 2 points, right, a and b, where b is greater than a, right, where b is greater than a, and if f of b, the value of the function, is greater than f of a, the value of function at a, for all values of a and b, then we say that the function is increasing, correct? That is the basic condition. Okay, so whenever you see a function, just test with 2 points, and if their values, for example, at a we have a negative value, for b we have a positive value, and a is any point to the left of b, every point to the left of b has a lower value than the point on the right, and therefore the function is increasing, right? So that is how we see increasing interval, and we say for this function the increasing interval is, or the interval of increase is, from negative infinity to positive infinity, and that is increasing interval or interval of increase for the function, right? Can you give me more examples for such things? How about this function? A cubic function. In this case also, you will observe that any point on the left side has a lower value than a point on the right side, and so it is also increasing in its domain from minus infinity to plus infinity. Correct? We can have more examples like this. How about square root function? In a square root function also, the function is always increasing, but here the domain in which it is increasing is from 0 to infinity. That is the interval during which it is increasing. Well, there could be few functions which are decreasing. For example, if I have 1 over x, you see, as we move from left to right, the value decreases. However, there is a discontinuity at 0. And then from 0 onwards, if we move towards right for positive values, again the value of the function decreases. So what we see here is that all along its domain, the function decreases. And so in this case, we are talking about decreasing interval for the function, right? So it decreases in the interval from minus infinity to 0. 0 is not included, and which you can write as union 0 to plus infinity. Correct? So that is the duration during which this particular function is always decreasing. Amongst the parent functions we have learned so far, in fact, this is the only function which is always decreasing. There are a few other functions which are always increasing, but what I will do is, I will write them after reflection on y-axis. For example, exponential function when reflected. Well, this is actually the reflection function. exponential function. So let us say I have a function here which is 2 to the power of x but with a negative sign. So what I've done is I've reflected the function. Do you see that? This is a transformed function, not the original function. So at times you can have a transformed function, and here you see that the function is always decreasing, and the interval for decrease is from minus infinity to plus infinity, right? At times you can sketch a piecewise function which could be always decreasing, right? For example, you can have pieces combined together as like this. It shows that the function is decreasing as you move to this point, right? And from here the function could be combination of another function. So a function like this could be always decreasing. Well, at present I have taken both these values at a, and that gives me a domain from minus infinity to plus infinity, the domain in which this piecewise function is decreasing. If, however, I would have taken this point at a point b, then there would have been a discontinuity in the domain also, right? So take care of that. But the whole idea of this video is to let you know that there could be many functions which will be always decreasing or always increasing in their domain. So look for them carefully, and whenever you list the interval, be sure to include only the domain in which they are increasing or decreasing. I hope that helps. Thank you.